Hello everyone, let's talk about another easy problem on Leetcode today. Ugly number, Leetcode 263. In this problem, we are given an integer n and we should return true if it is an ugly number, otherwise we should return false. A positive integer is said to be an ugly number if its prime factors are limited to 2, 3 and 5. So this problem needs a bit of a math primer. So let's first look at what prime numbers are. A prime number is a natural number greater than 1 that has no positive dividers other than 1 or itself. So a prime number can only be divided by itself and the number 1. So for example, take the numbers like 2, 3, 5, 7, 11. So all of these numbers are either divided by themselves or 1. So this is prime number. Now let's look at what factors are. So factors of a number are numbers that divide it exactly, leaving no reminders. For example, let's take number 12 and see what are its factors. 12 can be divided by 1 and 12 itself. Then 2 by 6 also gives us 12. So when we divide 12 by 2, we get 6. Or when we divide 12 by 6, we get 2. Similarly, 3 and 4 are also 12's factor because when we do 3 into 4, we again get 12. So numbers 1, 2, 3, 4, 6, 12 all are its factors. And now we come to the last point, and that is prime factors. Prime factors are prime numbers that when multiplied together result in the original number. So basically we represent the number purely as a product of these prime numbers. So let's look at 12 again. For example, we had 2 and 6 as factors of 12. Then we can see that 2 is a prime factor but 6 is not because 6 is still divisible by 2 and 3. So 6 is not a prime number. But if we take 6 as 2 into 3, then 12 can be written as 2 into 2 into 3 or 2 square into 3. And now because both 2 and 3 are prime numbers, they are also the prime factors of 12. So this is what prime factors mean. And now we return back to the examples. In example 1, we can see that 6 is an ugly number because only prime factors it has is 2 and 3, which is limited to 2, 3 and 5. So we will return true in this case. Then in example 2, we can see that n is equal to 1 and it does not have any prime factor at all. So in a way it is also limited to prime factors 2, 3 and 5. So that's why it is still an ugly number. So that's why we will return true again. Finally, we come to 14. And here we can see that we can write 14 as 2 into 7, right? So 2 is a prime factor, which is in this set 2, 3, 5, but 7 is not. So in this case, that is why we will return false. Now our task is to find if the number is ugly or not, right? So we only care about prime factors 2, 3 and 5. So how about we just continue to divide the number by these three numbers till it is not divisible by any of these three numbers, and in the end if we get final number as 1 from all of these divisions, then it is an ugly number, otherwise we will return false. Now let's look at it with the example. So suppose we take 20 as a number and now we try to divide it by 2 if possible. So is 20 divisible by 2? And the answer is yes, and we can check that using modulo operator. So if 20 modulo 2 is equal to 0, that means 20 is divisible by 2. The modulo operator returns the remainder of a division of two numbers, and when a number A is divisible by number B, then A modulo B is 0. That is, we get remainder as 0. So here also 20 modulo 2 is 0. That means 20 is divisible by 2. So we divide this number 20 by 2 and we will get 10 now. Now we again try to divide this number by 2. So we check, is 10 divisible by 2? And the answer is yes, because we again get 10 modulo 2 as 0. So now we will divide this number by 2. So we will get 5. And now we will check, is 5 divisible by 2? And the answer is no, because we get 5 modulo 2 as 1, which is not 0. So that is why this number is not divisible by 2 anymore. So now we will try the same approach with 3. So we will check, is 5 divisible by 3? And the answer is no again, because we will get 5 modulo 3 equal to 2. And now we will try to divide the number 5 by 5. So we will check, is 5 divisible by 5? And the answer is yes, because 5 modulo 5 is 0. So we will divide 5 by 5 and we will get 1. And because we have reached 1, that means this number was only divisible by 2, 3 and 5. And that's why we will return true. Now let's look at a negative example just to test out our approach. Let's take number 14. And first we will check, is 14 divisible by 2? And the answer is yes, because 14 modulo 2 is equal to 0, right? So we will now divide 14 by 2 and we will get 7. So now we will check, is 7 divisible by 2? And the answer is no, because we will get 7 modulo 2 is equal to 1, which is not equal to 0. So we will go to the next prime factor, that is 3. So we will check, is 7 divisible by 3? And the answer is again no, because we will get 7 modulo 3 as 1. So now we will go to the last prime factor, that is 5. And we check, is 7 divisible by 5? And the answer is no, because 7 modulo 5 is equal to 2 instead of 0. And now in the end we had only 7 remaining, which is not equal to 1, because if this number's prime factors were limited to 2, 3 and 5, we should have got 1, but instead we got 7. So that is why we will return false in this case. Now let's jump into the code part. So first thing we will do is, because ugly number is a positive integer and in the constraints n can be negative or 0. So if we see n less than equal to 0, then we should return false. Then we have a special case. If n is equal to 1, then we should return true, even though it does not have any factors. And now we have to do the divisions based on the primes 2, 3 and 5. So we will just run the loop on these prime numbers and see while number is divisible by prime. And we can check that by using the modulo operator. So if number modulo prime is equal to 0, that means remainder is equal to 0. So number is divisible by prime. If that is the case, we will continue to divide the number. And once we are done with all the divisions, then in the end, our number should be equal to 1. Now let's run this code. Cool. Let's submit this code. Cool. In terms of time complexity, it will be log of n. We can write number n as product of prime numbers. And because for ugly numbers, we only care about prime factors 2, 3 and 5, we can write number as 2 to the power of x, 3 to the power of y into 5 to the power of z. And there can be other prime numbers as well, but we primarily care about these only. Then to divide this number by all the 2's, it will require x steps. Similarly, to divide this number by all 3's, that requires y steps, and to divide this number by all 5's will require z steps. And now to get the values of x, y and z, we have to take log of both sides. So one time we will do log of 2n to get x, right? Similarly, we will do log of 3n plus log of 5n to get z, right? So it will be sum of these, and primarily log 2n is the largest because the base is smallest. So in the worst case, or for simplification, we can write it as log 2n or log n. So basically that will be the time complexity. And in terms of space complexity, we are not using any extra space, so it will be O of 1. I hope this video was useful to you. If it was, please like and subscribe. I have shared the code link in the description. Have a nice time. Thank you.